is thinking about functions. What do their graphs mean? So maybe we'll start with a very informal definition. So a function is some thing. There it says quantity. It doesn't have to be. That can be determined if you know some other thing. So here's an example. So suppose you stand on the ground and throw a bowling ball upward with an initial vertical velocity of 20 meters per second. Precisely the thing that you should not do. I don't see why you would. So physics predicts the flight of the bowling ball will follow, is modeled by the following formula. Negative 5t squared plus 20t with time t in seconds. And height in meters. Some people would prefer that negative 5 were replaced by something with negative 4.98 or something. Okay, that's closer to what physics actually says, but that's good enough for me. Well, what do you think? Given this information, if you know how many seconds it is after you've thrown the ball, can you determine the location of the height of the ball? Yeah, that's exactly what a function is. Let's do that. At time equals 0, what's the height of the ball? 0. And in fact, did you have to do any computation to know that? Yeah, if the model is reasonable, that better be. And, well, maybe we'll check that the formula, the model, is reasonable. Yeah. Things multiplied by 0 added together is all 0. What is the height of the ball after 1 second? Yeah. 15 meters. Is that in agreement with other people? Good. Well, yeah, maybe units are important. At time equals 2 seconds? Yeah, so at any time, well, let's see what thoughts people have on this, because maybe this is not so straightforward depending on how you think of it. Given any choice of time, can you determine the height of the ball? Folks vote yes. Anyone want the answer to be no? Yeah, sure. Why no? Okay. Could you use this formula to predict the height at like t equals negative 2 seconds? Yeah. It wouldn't make sense to use it. You don't know where the ball is before this person threw it. Presumably they were carrying it to the location where they would throw it for. But maybe yes is a good enough answer for that. All right, that's an example of a function. A function is a function from one set, usually a set of numbers, to a set B, in this class again a set of numbers, is any rule which takes a member of the first set and gives you a member of the second set. In this case, it takes a time, probably a positive time at least, and returns a height. That's another number. I guess it should be a positive number. Right, it would be silly if height were negative. The domain of a function is a set of all valid inputs for that function. So if you have some formula, you better not divide by 0. If you have some model, then its domain should really be all of the inputs which make sense to plug into the function. That's maybe a vague thing to say, but it's worth writing. All inputs which make sense to plug into the function. All right. So suppose you only want inputs for which the height of the bowling ball is actually given by the formula above. And let's try to compute the domain. So let's start by just thinking about some things that shouldn't be in the domain. Should t equals negative 2 be regarded as in the domain of that function? No. Should any negative? t equals 0, should that be thought of as in the domain? Yeah, it gives consistent edges. So it looks like the domain is an interval starting at 0 and going on for some amount. Do you think it should be 0 to infinity? I think people would want that to be the case. I hear one head nodding. Well, saw a head nod. I saw a head shake. Those of you who said no, why no? Yeah.
Because it'll hit the ground again eventually.
Yeah, eventually it'll hit the ground, right? And let's see what happens after it hits the ground. So if you think the formula up there, what is the prediction of what the height should be at t equals 10? So if you use the formula above, let's just see what happens. See, that would be negative 5 times 10 squared plus 20 times 10. That looks like the type of thing that we can probably compute. Yeah, I don't know, that's negative 500 plus 200. Is that negative 300? All right. So this formula predicts that by time negative 10, the bowling ball will have borrowed 300 meters into the earth, which is probably unreasonable. So it looks like eventually times stop being in the domain. I guess the time when it stops is when the bowling ball hits the ground. So let's find when the bowling ball hits the ground. How do you determine when the bowling ball hits the ground? What does it mean in terms of this model for the bowling ball to hit the ground? When it's back at 0. So I guess that means we want to find the solutions to h of t equals 0. All right, well, I guess maybe two options. We can talk, I can just pause for a moment. How many people would prefer I just be quiet and they figure out what the solutions to that equation are? Anyone prefer me keep talking? Okay, I'll keep talking. Those of you who prefer I wouldn't don't necessarily have to listen. Let's do it. So I want to solve that. I have a formula though. That's negative 5t squared plus 20t equals 0. What would you want to do if I were told to solve that equation?
Simplify.
Simplify. What simplification would you like to make?
Pull the t's out.
Yeah, that sounds good. Right. Two different things there are that there are two sum ends. They both have some t's in them. And that's a useful thing to do because the thing on the right is 0. So let's do that. That's negative 5t plus 20, another t, equals 0. Oh, cool. So that's a thing times another thing equals 0. What's the only way you can multiply two things together to get 0? One of them has to be 0? Yeah. So let's set each of those things to 0 and see what happens. I guess there's the easy one. What's the solution to t equals 0? Yeah, right? That's like a dumb question to ask. When t is 0, what is t? There's the other case, though. Negative 5t plus 20 equals 0. What are the solutions to that? I hear a 4. Does that agree? Awesome. All right, have we just discovered when the ball hits the ground? So when do the times stop being in the domain? After 4 seconds. Nice. So you can find domains by just, if you have something that's supposed to model some reasonable behavior, just determine what inputs correspond to reasonable behaviors. There are a few other names worth giving things. The set of all actual realized outputs of a function is called the range of that function. And let's determine the range of this bowling ball. I'll give you a single fact. Well, it'll be that fact. The ball is at its maximum height at time equals 2. So this bowling ball, what's the minimum height that makes sense for it to have? 0. And does it actually achieve that height of 0? Yeah. Right, it starts at 0. There's the minimum height. Here is a fact, which I will not try to justify right now. The ball attains its maximum height at time equals 2 seconds. Given that information, can you determine all of the possible outputs of the function? Yeah. What's the height at time equals 2 seconds? 20 meters. Did you have to do any computation to get that? No, it's like at the top of the page, right? Yeah. So it looks like the maximum height is h of 2 equals 20 meters. Is the ball going to achieve all of the heights between 0 and 20 meters? Yeah, somehow the ball's not going to like teleport at some point. It should travel continuously, hitting every height between. So it looks like we know the range. The range is all numbers between 0 and 20? Okay, that sounds like an interval. So the range is 0 to 20, and maybe we'll specify units. These ideas make sense? Good. Good, good, good. All right, so we'll wax a little bit more abstract now. I won't worry about where these formulas will come from or what they're supposed to model. Let's write down some formulas and see what things look like. So here's one, a function. Let's let f of x be the distance from the point 0, 0 to the point x, comma 1. And maybe we'll even just start with that. Let's try to convince ourselves that that's a function. If I give you a value for x, can you determine what that distance is? Yeah, not like do it, but is that distance actually a thing? It is. So this is actually a function. Let's try to evaluate it. Let's evaluate it at x equal to 2. So f of 2 is apparently the distance from 0, 0 to 2, comma 1. Is that something that you know how to compute? Maybe I'll just, in fact, be quiet and say, compute that. Tell me what that is. Groovy. So what is it? A hero root 5? Does anyone want me to talk through that? You are all very quiet, and sometimes it's hard for me to tell. Okay. Okay, people are happy. Right, this is also maybe a downside of the fact that I like provide these notes. Presumably some of you just were going ahead. All right, let's find the distance. So let's find a formula for this function. Not every function can be described by a nice clean formula, but this one presumably can. I guess the distance formula is probably useful. So the distance formula says that the distance between 0, 0 and x1 should be the square root of the difference between the x coordinates squared plus the difference between the y coordinates squared. Sound look like the type of thing that should probably be simplified? Yeah, right? 0 minus x is just minus x, but does the minus even really matter? No, it's getting squared anyway. Does that simplify any further? I don't think it does. Oh, maybe I'll do something like really wrong. How many people would want to see this and say that should be the same thing as like square root of x squared plus the square root of 1 is just x plus 1? Good, yeah, right. What's wrong with that? Yeah, square roots don't behave like that over addition. I know that's erasable, but that felt more satisfying to me. You can plug things more complicated than a single input. You can plug a formula in as the input to a function. And what does that mean? Well, we have a formula for what f of a thing is. F of a thing is given by that formula, square root of the input squared plus 1. So if you want to plug x minus 2 in as the input to the function, you can just do it. That makes sense? So you can compose functions. You can put a function inside of a function. Is that a type of thing that should be simplified? Do people want to go through the walk right now of simplifying it? Folks for yes, let's do some algebra and simplify? All right, let's do it. So I see that x minus 2 squared. Let's square that. And maybe I'll do one thing off to the side. So if you want to square a binomial, a thing plus or minus another thing, well, all you need to do is use the distributive law, I guess. And the shortcut for what you do when you do this is this like FOIL acronym, right? Take the first things, multiply them. Take the outside things, multiply them. Take the inside things and multiply them. And finally, take the last things and multiply them. Negative 2 times negative 2 is positive 4. Fair enough? So let's make that replacement. By FOILing, this is the same thing as the square root of x squared minus 4x plus 4 plus 1. Is there any other obvious simplification you should make? Yeah, what's that?
Adding 4.
Yeah, 4 plus 1 is 5. May as well make that simpler. Groovy. Cool. People feel all right? All right. If I give you another function like g of x equals root x, is it possible to plug that function g of x into f of x? Yeah. Maybe I'll even just like be quiet for a minute. Let you guys do that. Okay, so what is f of g of x? Yeah, Any simplification you can make to that? Yeah.
Can't you just simplify to the square root of x plus 1?
Yeah, so let's write down that, and then we'll write down a fact. If you take the square root of a number x and square it, you'll always get x with the following condition, provided that x is bigger than or equal to 0. What's that provided x is bigger than or equal to 0 doing here?
So it's not negative?
Yeah, you wouldn't want to take the square root of a negative number. Right, the square root of negative 10 squared isn't negative 10, it's just nonsense. Cool. Maybe I'll make one other related but only tangentially comment. If you take a number x and you square it, and then you take the square root, what do you think that should be? Yeah.
X.
If you recall from x, and that's almost right, yeah.
Could it be plus or minus x?
Yeah, it might be negative sometimes. And in fact, it's negative in very particular times. What's the square root of negative 2 squared? That's a lot to say without writing anything down. Let's evaluate that. What's negative 2 squared? 4. Okay, you told me what the end result is. So it looks like the negative sign kind of just goes away. What's a function we have already that like makes negative signs go away?
Absolute value.
Absolute value. That's what this is. So there are two facts worth holding on to. We could write down f of x plus g of x, and that's even easier. You just add the things. F of x is the square root of x squared plus 1, plus g of x is the square root of x. People feel pretty good. Let's ask about domains now. What's the domain of the function f? What are all of the valid inputs for the function f? Well, I guess here's a better question. Are there any inputs you can't plug into f? Alright, you see A no. Why no?
Would squaring it take the negative sign away, so that way it could be infinity to infinity?
Yeah, there's a good way to think about it. So let's write down some of that. So the thing under the square root must be non-negative. But let's look at what's under the square root. Is that thing ever negative? No, right? You square a thing, the worst you can do is 0, and then you add 1 to it. That's definitely not negative. Is never negative. The domain equals, maybe I'll write this multiple ways, all real numbers, negative infinity to infinity is another way of writing that. Every real number is between minus infinity and plus infinity. Cool. That seem reasonable? Alright, what about the domain of g of x? What's the domain of g of x? Yeah, g of x is the square root of x, so x had better be bigger than or equal to 0. So I guess there's one way of writing what the domain is. Maybe I'll write it also as an interval. And also write it as 0 to infinity. All right, what's the domain of f of x plus g of x? Let's just try to check. Are there any inputs for which f of x is not defined? Just f of x. F of x is always fine. So there are no problems running from f of x. Are there any inputs for which g of x is not defined? Yeah, negative inputs. And I don't know how to add a number with something that doesn't exist. So in order for f of x plus g of x to exist, both have to exist. F and g both have to make sense. So the domain is 0 to infinity. All right, what about f of g of x? And maybe, so this is a trick question. There are a few different answers that I would anticipate. So maybe I'll let people sit and think for a bit and see what domains they come up with. Yeah.
Should be all numbers greater than 3 to negative 1.
There's one option. I'll tell you that that's wrong, but we'll talk about why that's wrong in a moment. I suppose but it's a reasonable thing to think of as being right. Presumably you went to this formula and said, oh, the thing under the square root better not be negative. And there you go. Yeah.
From 0 to infinity.
I see also a 0 to infinity. And maybe we'll ask, why 0 to infinity?
Because 0 under a radical isn't, I don't think there's a square root of 0.
There is. Right, square root of 0 is 0. But, so that just means 0 is fine. But like, negative 0.001 would be bad. So let's talk that through. So here, in fact, is what I will say. So let's write down the formula for f of g of x. Not the thing we get after simplifying, but the original formula. F of g of x is the square root of x squared plus 1. And maybe I want to test these two. Let's see what happens when you plug in x equals negative 1. You would get the square root of negative 1 square rooted squared plus 1. Is anything wrong with that expression? Is anything bad about it? Well, there's a negative under a square root, right? Let's maybe focus on what's going on. That. I see a minus in a square root. Right, and that's bad. So here's the payoff. Whenever you ask for the domain of something, check the domain before you do any simplification. When you do a simplification, you might accidentally emerge the domain, which is exactly what happened right here. If I give you this function, the domain is negative 1 to infinity. But before you make the simplification, stop. Cool. How do people feel like that? Pretty okay? So there's the caution. Ooh, that's exciting. You always check domain before simplifying. And in fact, right, so as we saw, given any two functions, you can formulate f plus g of x as f of x plus g of x. F minus g of x will mean f of x minus g of x, f times g and f divided by g. So, if someone tells you a function f of x is x squared plus 1 and g of x is x squared minus 1, you can find the formula for f divided by g. F divided by g of x is the same as f of x divided by g of x is x squared plus 1 over x squared minus 1. That's all it means. People feel pretty good? And I know it says here something about computing a domain, but maybe I'll push that off in the interest of hitting more stuff. So you can find domains of any of these combinations of functions in a way that makes really reasonable sense. If I ask you for a sum of two functions and ask you for the domain of them, well, in order to make sense of f plus g, you better be able to make sense of f, and you better be able to make sense of g. And could anything else go wrong? Are there any two numbers that you can't add together? No, you can always add any two numbers, right? So the only thing that could go bad is f or g might not be defined. If you want the domain of f plus g, it's just all inputs which are both in the domain of f and in the domain of g. That's all. So let's use that to do a thing. Let's hit these three, f, g, f plus g. So by looking at those two functions, what's the domain of the function f? Or maybe what isn't in the domain of that function? Well, let's see. Let's look at every ingredient one at a time. So f of x is x plus 1 divided by x minus 1. And let's focus just on the purple bit. Is there any number that you cannot add 1 to? No, so there's no problem just coming from purple. And if you just looked at the bit in blue, don't worry about the fact that there's division yet. Is there any number you cannot subtract 1 from?
1.
All right, you answered the more relevant question. Yeah, so the number that we can't see in the denominator is 0. So I better not see a 1 for x, because that would give me a 0 in the denominator. Can anything else bad happen in that formula? No, that's like division by 0 is the only bad thing that could happen there. So the domain of f, the denominator, x minus 1, can't be 0. So the domain is all numbers but 0. People feel pretty okay? Maybe I'll write that in one other way. I like interval notation, so I think we can write that as intervals. Oh. One is the problem. All numbers but positive 1. So all numbers but 1, that means everything to the left of 1 is good, everything to the right of 1 is good, just 1 is bad. So in interval notation, that's negative infinity to 1, together with 1 to infinity. What about g of x? What bad thing can happen if you just look at the formula for g of x? Or maybe just, I'll ask the actual question. What's the domain of g of x? Can't have negative 1. Negative 1 would be bad. But that's the only bad thing that could happen. So the domain of g of x should be all numbers but negative 1. Cool. And now, without writing down anything about f or g other than what's written on the previous 2 lines, what's the domain of f plus g?
all numbers except 1 and -1.
Yeah, great. Right? F better be defined so x can't be 1. G better be defined so x can't be -1. But otherwise everything's fine. All numbers but plus or minus 1. And right. Both of these answers are equally correct. Which one you prefer will depend on how much you like intervals. All right, the same logic. Don't do any algebra. We'll do algebra in a moment. What should the domain of f of x times g of x be? The same, right? In order for f times g to be defined, f has to be defined, so x can't be 1, g has to be defined, x can't be -1. So, same as 3. All numbers but plus or minus. All right, so let's talk about division. Let's talk about f divided by g. The domain of a quotient f divided by g is all inputs which are in the domain of f and in the domain of g, and for which g of x isn't 0. Does that seem reasonable? Yeah, right. If I'm going to divide by two things, both of them need to exist. I can't make sense of nonsense divided by 5. But even if I know what both numbers are at the bottom 0, that's fine. So let's use that. Let's compute the domain of f divided by g. So let's just list the things. F must be defined. And we've seen that that means x equals 1 is bad. G must be defined. So x equals -1 is bad. But we also have g of x equals 0 is bad. If you look at the formula for g of x, can you set that equal to 0 and tell me what x is? Let's do it. So that's x divided by x plus 1. There's g of x equals 0. If you wanted to solve that to see what x is, what would you want to do to it? Or alternately, just what's the final, what is the solution to that? I thought it 0. People agree? People want me to talk through how to think about that? All right, awesome. Yeah. So that means x equals 0 is bad. So I found a list of like 3 bad numbers. So the domain must be everything else. Oops. Domain is all numbers but 0, 1, -1. Those ideas make sense? Cool. So there's a particular type of function that I want to start introducing now. And these are the so-called linear functions. And we talked about something quite related last time, namely a linear equation. So a linear function is any function which can be put into the form f of x equal to mx plus b with m and b constant. as in things that don't depend on the input x whatsoever. So here's one. In fact, this is the formula which converts from degrees Celsius to degrees Fahrenheit, if you like. Is that function linear? What's m? 9 over 5. What's b? Great. How about this function g? G of x equal to x times x plus 1. Is it linear? Folks for yes? Folks for no? So, this was a trick question. Those of you who said yes, then what should m be? Well, I guess now you're not going to answer. Well, it looks like x, right? So it looks like you really want m to be x and b to be 1, I guess. Well, what's wrong with that choice of m? Yeah. Yeah. All right. M equals x is not constant. So this thing is not linear. Good. What about h of x equal to 3? Is that a linear function? Folks for yes? Anyone for no? All right, those of you who said yes, what's m? 0, right? You can rewrite this as 0 times x plus 3. And you see, I chose my words very carefully. A function isn't linear if the formula you're given for it has the form f of x equal to mx plus b. If it can be put into that form, it is linear. And that can be put into that form. So this is linear with m equal to 0, b equal to 3. And in fact, here are the graphs of the 3 functions. So this function you told me is linear. This one is not. That one is. So the 2 functions there that are declared to be linear functions. What can you tell me about their graphs? Yeah, the graphs are lines. That's why they're called linear. Just like we saw last time. So, let's start talking about some properties of linear functions. So, well, the first is one that won't seem terribly fancy. If I give you a line with 2 points along that line, you can compute the slope using those 2 points. If I give you this line and these 2 points on it, then you can compute the slope as the rise over the run. If you like your Greek symbols, often delta is used to indicate change. The rise is the change in the y-coordinate, the run is the change in the x-coordinate. And now we can actually just write down what those are. The change in the y-coordinate is y2 minus y1 over x2 minus x1. People feel pretty good? How many people would have preferred to write y1 minus y2 over x1 minus x2? Would that have given the same answer? Let's compare. So what if it was y1 minus y2 over x1 minus x2? How do these 2 things compare with each other? Yeah.
It's still just the difference between the two.
Yeah, they're still like, it's the same. In fact, the way to see that is, that's the same thing as negative y2 minus y1 over negative x2 minus x1. Do those two negative signs cancel? Yeah, negative divided by a negative becomes positive. Those two signs cancel. So it doesn't matter what order you do things in as long as it's consistent. So let's use this philosophy to compute some slopes. Eventually we'll get a formula which will not be a surprise. So here is a linear function, y equals 2x minus 4. What do you think the slope of that should be? 2, right? Like somehow this should be the slope, but let's check that it's the slope by using the fact that we have a formula for slope. So let's find these 2 points. When x equals 0, you see a point x equals 0, and what y value do you see, what y value do you get when you plug in x equals 0 to that function? Negative 4. And x equals 1, what y value do you get when you plug in x equals 1? And here a negative 2. Let's compute the slope. So the slope should be change in y over change in x. y2 minus y1, negative 2 minus negative 4, over x2 minus x1. If you simplify that out, do you get 2? Hope so. I see a double negative, let's simplify that. Negative 2 plus 4, that's 4 minus 2 is 2, divided by 1. Yeah, that's 2. So the important formula that you told me already that we just checked is the slope of any line, y equals mx plus b, is always that quantity. And I think instead of proceeding from here, I'm going to look at the plot and see that I'm quite low on time. And so maybe I'll give you an overview of what some of the remaining things will be, and we'll hit them next time. So you notice that there are like 2 parameters you need to know to fix a line. You need m and you need b. So this somehow means that if I tell you 2 facts about a line, you probably know what that line is. For instance, maybe I tell you here are 2 points on the line. There are 2 facts about the line. Probably that's enough to know what the line is. Maybe I tell you the slope and a point on the line. That's probably enough to tell you what the line is. And we'll do exactly that in these examples. You can do them ahead of time and have a really light beginning of lecture next time. Cool.